And in the meantime, they should be doing, help them really crack down on that and make them put in above ground temporary systems. Hi. Hey. I'm Kim.
Nice to meet you, Stephanie Davis. I feel like we've met already.
I know.
How you doing, Wagner? How you doing?
Is there any agenda?
Yeah. Agenda. Your copy is right here, Kev. Yes. Ah, nice to meet you. Oh, substitute cushion.
How many calories do you have?
No, the plant is pretty much situated over a groundwater. Question for you too. Groundwater divide.
Yeah.
Okay. And my understanding is, if you're north of the groundwater divide, water moves basically northward into Ohio and south.
Yeah.
South it goes
It's a skill.
into the ocean.
Right.
This question about the
Correct.
groundwater divide
Kevin's going to cover some of that today.
My question is,
is very important.
there's stuff that comes out of the monopolies.
Right.
Does that accelerate us?
On or about the landfill?
Does it accelerate us out?
Divide?
Or does it dissipate?
Yeah.
Or does it concentrate?
Right here.
You know, like there are 5 different things that can go on at the same time.
Well, just so we get the geography correct, the groundwater divide is actually toward the south side of the landfill, and the sewage treatment plant is definitely north of the divide. Okay, so southerly flow is not in the picture for the plant. Basically, downward flow.
All right, shut the AC off. 18. How are you? Right, shut it off. Shut it off. Thanks for all your mail. Yeah, we'll see how it goes. We'll be ready. Got a question already?
Sorry?
some of them are names that go back, 13 generations. Oh yeah, my great grandfather did this one in 1880.
You had nothing to do, so that's how you feel in the morning.
Now I was working at the nature preserve.
Winter is painless, like everybody else, so it's good.
I go salad every
Oh, you do?
winter.
Okay.
This year I didn't have.
Sounds easier.
All right, 1 minute. Finish up your conversations. We're going to start in about a minute. And
Go ahead. I think it's the easiest. Is this the thing for the plasma, for the smartphone?
Oh, you like that?
Yeah, so I'm just gonna leave it, don't touch.
I'd still like
I think looks like you're probably giving me a first round, I guess.
No, author.
Well, it's just, these are, those are presentations, okay. So environmental discussion.
This is what we put in the report for this.
Right.
This is our recommendation.
In terms of?
This is where the plume is. Each one of those is 2
ladies and
plus.
gentlemen, we
got one more
have your
person.
attention, please.
That's the
We're going to begin taping
2010.
right about now.
This is 5.
So if we could have your attention, please. Thank you.
I want to welcome everybody and thank you all for coming, taking part of your Saturday to be here for this forum. And I'm really proud and pleased to have so many distinguished people on our panel. And working with Dominick has been a pleasure, and he's going to introduce our panel in just a minute. But again, I want to thank everybody for being here. But first, introduce some people that are distinguished guests in the audience. And first among those is Supervisor Bill Wilkinson. Thank you for being here. Councilwoman Teresa Quigley, thank you for being here. And I see Pat Manser walked in, former Councilwoman Pat Manser, thank you for being here. Chair of the Nature Preserve is also here, Zach Cohen, and any other distinguished people that I didn't. Oh, Kevin McAllister, our baykeeper, is here. Thank you so much. And anybody, if I forgot, I'm really sorry. So hope you forgive me. Again, we are going to focus this forum on the scavenger waste plant. The town of East Hampton has a municipal facility that is aging, and we need to know as a municipality where we want to go with this particular plant. We have options in front of us, and these panelists, I think, can help address some of those options. They're here so that the community can make some informed and educated decisions. So we hope you enjoy what you're hearing. This isn't a scavenger waste plant is, as we all know, takes care of our effluent. It's a necessary piece of a municipality to be able to take care of their waste. And this is the forum that I hope we can discuss some of those options. In the bigger picture is always concerning all of our septic waste systems in the town. But today I hope we just can kind of focus on just the scavenger waste plant. But we know in the larger realm is the idea of how we're going to take care of all of our aging septic systems that are in the town of East Hampton, actually in a lot of parts of Long Island. So without further ado, I'm going to turn it over to Dominick, and he's going to introduce our panelists. And again, thank you so much for being here.
Thanks, Sylvia. Dominick Stanzionne. I have the pleasure of introducing a really excellent panel of experts, engineers in solid waste management and hydrology.
I would like to say first also that who's not here, we had invited the management team at Severn Trent to try to attend. They could not come. And we also invited members of the Suffolk County Department of Public Works who are familiar with the operations and of scavenger waste plants and waste plants. We do have a commitment from both of them to talk to the board in the future on this matter, and they will have the benefit of seeing the tape of this program. So without any further ado, let me introduce Arthur Malman, who is the, I still believe, chairman of the GGG, despite all efforts to get away from that. And also chairman of the town's Budget Finance Advisory Committee, who held a forum of their own on this very subject recently. Mark Wagner, who of the Cameron Engineering is a key consultant to the town on scavenger waste issues. He's here to discuss his expertise. Kevin Phillips, principal in the firm of Fanning Phillips Molnar, who provides water testing services and hydrological expertise. Did I say that with fumbling? Okay. His able partner, Stephanie Davis, of the same firm. Kim Shore, who you all know, is our newest, and we're very grateful to have Kim join the town as director of our environmental services. I forgot what we call it. Kim, title?
Environmental Protection Director.
Our environmental protection director. Thank you. And Pio Lombardo of Lombardo Associates. Lombardo Associates' expertise is on communities that are non-sewer. He has spent his career developing systems and consulting with governments on small communities who don't have sewers, and trying to deal with the issues that sewering solves, but that cannot be solved in communities that don't have sewers. So I think the way it's going to work is that we're going to have each speaker, Arthur is going to speak for a few minutes, and then each speaker is going to have about 10 minutes to make a presentation, and then following that, there's going to be a conversation amongst the people on the forum about their respective presentations, and then we're going to open it up to questions. If you have questions, please fill them out on a little 3x5 card. We'll try to get to them, and then we'll open it up to questions from the audience and see if we can't keep this thing in a tight 2-hour framework and end on a high note. So that's what we're going to try to do. Okay? Good.
I want to recognize one other person that has walked in, Tom Noble, former Councilman Tom Noble. Thank you, too, for being here.
Okay.
So
Arthur, let me
appreciate
be
it.
the first to introduce you. Thank you very much. You can stand here, Arthur, since you'll be the mic.
Sylvia asked me to give you a little background about what came out of our forum a couple of weeks ago. And she allocated, she said I could be speaking for 10 minutes, but if you don't mind, I'd like to try and do it in 2 or 3 minutes, and so we can move on to the substance of what's here. Basically, our forum tried to look at this map, which I hope most of you have, and try to figure out what was happening with groundwater. In particular, we talked about the fact that the landfill and the plant, the scavenger waste plant, lie along this very dark line, which most people don't know about. It's called the groundwater divide. In simple terms, anything that is north of that, when it rains, it goes toward the Sound, and if it's south of that, or the Bay, Peconic Bay, or if it's south of that, it goes toward the ocean. So the water goes either north or south, depending on which side of that divide you're on. What makes it a little tricky for us in our landfill, capped landfill, and the plant is it sits on the groundwater divide. And as a result, while most of the plume that has emanated from the landfill is moving north and possibly west, it may also be moving down into the sole source aquifer. And hopefully some of the folks here today will talk about that problem. That also leads into the question of what does the plant's effluent, the water that comes out of the plant, do to that plume? Does it help disperse it? Does it bring other elements into it that make it more concentrated? Does it push it faster north? Does it push it faster down into the aquifer? Those are some of the issues hopefully we'll touch on today. For those of you who are not familiar with the plant, and probably before I even touch on the plant itself, let me give you a little bit bigger picture. As people have suggested, our wastewater treatment plant in the town of East Hampton has really 20,000 parts. Everybody has a cesspool or a septic system that is part of what you might consider an uncoordinated, decentralized wastewater system. And those things all should work together to some degree. And there are some sludge or elements that precipitate out in your home septic or cesspool that periodically gets pumped out and brought to a scavenger waste plant, either in East Hampton or one of the larger plants up island. And what we're talking about now is where our plant in East Hampton should or does fit in and how it fits in. And what came out of our forum were two things. One, that in order to really make the intelligent decisions about the plant and its effect on the groundwater, which is what we're ultimately concerned about, is we really need a lot more and more robust environmental testing to understand what's really happening before we make any long-term decision. Short-term decisions are easy. The other thing that came out of it was we probably should figure out where this whole wastewater handling system is going. And can we come up with an environmentally and economically sustainable long-term wastewater management plan for this town, against which we would review the position of the wastewater or the scavenger waste plant up on Springs Fireplace Road. And much as I'd like to talk forever, that is pretty much the background from what we were discussing at our forum a couple of weeks ago. Okay.
Thank you very much. Sure. Very kind of you to keep it brief. Mark Wagner, please.
You said brief, right?
No, you can talk as long.
Okay, I'm Mark Wagner with Cameron Engineering. I'm just going to dovetail a little bit to Arthur. I want to just give an overview of the status of the scavenger waste plant. I do want to talk a little bit how the scavenger waste plant fits into the, right now there is no overall wastewater management plan within the town, but there are, I think, some misnomers as to what exactly is the plant doing. The town of East Hampton is unsewered, much like 70% of Suffolk County. 70% of Suffolk County relies on on-site systems to handle the wastewater that's generated within the home and discharges. The type of effluent that comes out of everybody's septic tank is pretty much the same. And over time, those systems will fail, usually at the most inopportune time, somebody's birthday or wedding or confirmation. And what the scavenger waste plant does, before the plant came online back in the mid-'80s, the septage used to be dumped in open lagoons adjacent to the landfill. That was the mode of septage disposal, and that was the mode in many other places. Town of Brookhaven landfill had one, Riverhead landfill had one, and in about the mid-'80s, the septage plants came online. These were funded to the great degree, 85%, in some cases 92% funded by the federal government. Town of Riverhead got a scavenger waste plant, Town of Southold got a scavenger waste plant, East Hampton got a scavenger waste plant, Town of Huntington got a scavenger waste plant. all about the same type of technology, some variation in sizes. Unlike those other facilities, those scavenger waste plants are pre-treatment and they discharge into a larger wastewater treatment plant. Town of East Hampton is the only scavenger waste plant that discharges to groundwater. But that being said, the waste that comes to the town of East Hampton scavenger waste is picked up by carters and delivered to the site. The other 364 days that's where that septage came out of the ground, there is still effluent discharging from those on-site systems. So possibly, maybe PO will talk about the fixing of the scavenger waste plant will not have any impact whatsoever on the discharge from the on-site systems. The scavenger waste plant is taking the solids, the residuals on the bottom that are collected, brought to the plant, treated to a very high degree. And somebody asked me and said, what is, if we try to put things in perspective, what is the discharge of the scavenger waste plant equal to, let's pick the constituent nitrogen, which is of a concern in groundwater. The discharge from the scavenger waste plant at an average of 30,000 gallons a day, with a 10 milligram per liter effluent, which is their permit standard, would be equal to the discharge from 22 homes discharging at 45 milligrams per liter, which is the standard number for an on-site system. So just to put things in perspective, from a nitrogen standpoint, if you erased the scavenger waste plant and it disappeared and you put 22 homes there, the nitrogen going into the groundwater would be the same. So where does that leave us? The town is faced with some important decisions. The plant has been experiencing violations of its speedies permit, which means it's non-compliant. A lot of those violations are associated with BOD, that's biochemical oxygen demand, nitrogen, not significant. The nitrogen and the BOD are connected because there's a process at the plant. The plant, as you may expect, gets a lot of flow in the summertime. In the wintertime, there's very little flow. So it's a biological system. It's very difficult to operate December, January, February, March, because this biology likes consistency. There isn't food coming into the facility. It's cold weather, nitrification has difficulty. It's a temperature dependent. And right now, we're in the summertime. The plant, if you are aware, the town filed with the state of New York a corrective action plan. And the first step in the corrective action plan was to cease the discharge from the facility. So as of January 1st, there is no discharge from the facility. There are no more violations occurring at the facility. The town is now using that time to evaluate, does it stay in the scavenger waste business? Is the scavenger waste plant going to play a role today, tomorrow, 5 years, 20 years, 30 years down the road? Will it be a transfer station only? Will it return to meeting standards? Will it be, and if so, will it be run by town forces or by outside forces? Or do they put a lock around the gate and say we're out of the scavenger waste business? I can tell you my personal feeling regarding the closure of the facility, that if you were to close the facility, the chances of reopening a scavenger waste plant or even a wastewater plant 5, 10, 20 years down the road would be a very difficult thing to do. So that's just one of the things that's in the background that the town is really grasping with, because all these options have costs associated with it, and all these options have either a loss of a service or possibly an increase in the service. So it's very important that the town, and the clock is running relative to the state on making some of these decisions.
Thank you so much, Mark. Appreciate that very much. Next would be Kevin Phillips, Next would be Kevin Phillips from the firm of Fanning Phillips Molnar.
file it is? Oh, great. Okay, great. I want to first acknowledge the members of the town board and the citizens of East Hampton, and like to thank the town board for inviting me to discuss this issue. And I have a couple of slides that I want to go through that I think can clear up some of the questions that have been put forth on the interaction between these two plumes. And I have a couple of slides that focus on the plume for the landfill. And there's some very interesting and very good news on the landfill that you're going to hear today. So the topics that we're going to be covered, can everybody see that? Because I can't. Anything to help me. Oh, my. Who's in charge of the IT here? My pointer doesn't work. Laser pointer doesn't work on the screen. Okay. I don't think so. This works. Try. See how?
Does this make it better or worse? Well, she can't get it on the TV. It's gonna look great on TV. That's the option. So the camera can capture it perfectly for the taping. So if we can live with it, that'd be great, because you'll have another opportunity to see it with clarity on the tape.
Well, we will live with it. Yeah, we'll live with it. I'll explain things. If I have to, I'll go up to the screen. The topics that we're going to cover today is the FPM services. I'm going to briefly go over that, how we got involved in 1989 with the landfill, and the hydrologic setting of the landfill, which is Arthur talked about one of the unique aspects of this landfill and the scavenger waste treatment plant is that they're very close to a groundwater divide. And I'll talk a little bit about that. The groundwater monitoring that we've done over the years, the 2003 groundwater model that we put together for prediction of how this plume was going to, this is the landfill plume now, how this plume was going to dissipate over the years and where it was going to go. It was very important to know the path that it was going to take as well. And the recent plume conditions, which, as I promised, will be good news for the town. And then we're going to get into the scavenger waste treatment plant, the layout and the monitoring. And we were involved in monitoring for about a 4-year period out there. And I'm going to show you some of the results of that monitoring. And then we're going to get into the final slide, which is the discussion and summary. So the next slide really goes over the work that we've done at the town, and I understand that you can't read this, and I'm not going to go through it, but I just want everybody to know the message here is that we've been working out on the landfill and in this area, in the area of groundwater hydrology, for 23 years, okay? You'd think we'd get it right by now, but in fact, no, that we have it right. And but we've been out there for quite a long time. So it's like we've got a lot of experience out there with many, many projects, including closing the old lagoons. The septage used to go into lagoons, has been mentioned, I think by Mark, and those lagoons were considered a Superfund site, and the town actually hired us to do the sampling in there and removal so that the site could be closed from its Superfund status. So it was a New York State Superfund site before. This is the location of the scavenger waste treatment plant. That's what that dot is. It's quite a large dot, and it also represents the location of the landfill. And this is what Arthur had started out this. It is a unique location in that any facility that is on a groundwater divide, theoretically, the water that leaches through the landfill theoretically goes straight down. Okay, now that's a theoretical issue, and then on the north side it turns up and goes over to 3 Mile Harbor, and on the south side it goes to the ocean. It goes down and then up to the ocean. And yes, water can go topographically up, but always down gradient. Okay, I'll explain what that means in about 2 hours. But water actually flows upward into the bay in this case. In our case, it is almost on the divide, but not quite. And so we're fairly confident that the flow is going north, and we're fairly confident that it is going into the apex of 3 Mile Harbor. And I'll show you some slides of that from our model. If you look very carefully on that, and I know you can't see it, but the groundwater table is a table, and as the fork continues to montour, the table represents kind of like half of a pipe, okay, where the table builds up in the middle, and just like a watershed, any water that falls on a mountain to the north will flow through the north. Any water that flows to the south of a mountain will flow to the south. So it's kind of like the same physical concept, but you have to picture it under the ground and you can't see it. And that's why people have such a difficulty understanding this. You just can't see it because it's 90 feet below the ground at this location. Okay, there is 90 feet of unsaturated zone in this location. Okay, so what you see on there is actually the contours of the groundwater table, and that's what tells us where the groundwater divide is, and it tells us which way water molecules are going to move in the groundwater system, and everywhere in the groundwater system, water is moving. Slowly, but moving. Okay, this is a picture in 2001. Okay, this is one of the first pictures that we pulled together, and as hydrogeologists, groundwater hydrologists, we know that this location is going to have a plume that somewhat goes vertical. We don't know how vertical it's going to be, but we know it's, in addition to being horizontal flow, there's going to be vertical flow. So when you're monitoring this, especially for the state, we are going to slice this aquifer to see what kinds of concentrations exist in the shallow, intermediate, and the deep flow. Okay, the shallow, intermediate, and deep flow is very important, and we install wells in the shallow, intermediate, and deep flow to give us a two-dimensional picture of a three-dimensional body of mass. If you can think of a sock starting in the shallow zone and then going into the deeper zone, that's what it actually looks like. Okay, but this is a two-dimensional picture of a three-dimensional mass, and it's very important because the shallow zone shows concentrations as high as 100, and the deeper zone also shows concentrations of higher 100, but it's much bigger. And I want you to keep that picture in mind because I'm going to show you later pictures in 2006 and 2011 that are going to show that those plumes, the shallow plume is going to be gone, and the deeper plume is going to be much smaller. And that's a very good thing.
Excuse me, Dr. Phillips, can you bring that screen closer? It's very hard to see.
We had that discussion.
Would these be posted somewhere? Would the presentation be posted?
Absolutely.
Okay, so you'll be able to download it.
We'll get your stuff on the town website. You'll be able to get it.
Okay, Dominick's threatening me here with time, so I'm going to move on here. And I'm going to show you what the model we did in 2003 looks like. And I just want to show you here, and unfortunately you really can't see the flow lines here, but the picture on the right is a kind of a micro look at the site. You can see there the landfill, and the red is our prediction of where the plume is going to be in 10 years and how it's going to dissipate in 10 years. And you'll see there that it really doesn't get above Accabonac Road, and it looks like it's not moving very fast, and the reason for that is because some of it's going deeper. Abraham's Pass. And the other thing that you can't see on there is there are blue lines, and they're called path lines. And what we do in the model is to drop particles into the model, and we say to the model, you know, track these particles along and show us where the velocity vectors in the groundwater actually exist, and so that we know where water is going to flow. And it's very important to distinguish water flow versus a plume. And that's what this slide is intended to do. A plume means that there's some kind of mass, some contaminant mass that we want to keep track of. And that contaminant mass actually degrades. Okay, so I'm going to show you some pictures here that'll show you that the mass is degrading, and it looks like there's no groundwater flow. There's always groundwater flow, always. Okay, this other picture on the right is a macro picture, and the little green area there is the path lines. It is not a plume, okay? It's the path lines of water molecules as they enter the aquifer system and exit. Their final destination is the bottom, the southernmost point of 3 Mile Harbor. This is the slide that is extremely important to the town, because the slide on the right, the 2006 slide, is actual data. What I talked about before was a model, and a model is a three-dimensional mathematical representation of the real world, and sometimes it can be difficult to match the real world. This is real data. 2006, you can see here, this is a plot of the deep plume, okay? There is no shallow plume except for one single well. One single well, stubborn well, still has some VOCs in it, okay? These are the chlorinated hydrocarbons that we're monitoring out there at the landfill. But the shallow plume is gone, and that's a great thing. 2006, the shallow plume is gone. The deep plume just, you can see there, goes over the northern portion of the golf course and stops. Okay, that's the 10 part per billion line, and it stops there. Now, I want you to compare this to the 2011, which is right next to it. That's 5 years. And what you see is that the plume is shrinking. And that's great. That means that there's less mass involved. Something happened to the mass. You can't have that without having the mass change. And that's a very good thing. In addition, what you see there is that the forward advance of this plume has been stopped. This is a stable plume, and it's reducing in mass. And that's all due to natural attenuation. Nothing, the town isn't doing nothing out there to treat this. There's no injections of fancy bugs or oxygen material or anything like that. That's a natural attenuation. Okay, move on. This is a picture of the scavenger waste treatment plant. As I said, we had a contract to monitor the scavenger waste as the effluent goes into the ground, okay, travels 90 feet into an unsaturated zone where it gets kind of filtered out, and then it hits the water table and then begins to migrate. Again, its ultimate destination is going to be the apex of 3 Mile Harbor 2. And there are some observation wells out there, but the observation wells, you can see that that spreadsheet that's been put on the top. Those are the samples that we took, I think 99 to 2001, Steph. And the only parameters that are being investigated are nitrogen and total dissolved solids, and that's probably inadequate for this plant, especially since some of the notices of violation that the plant has include mercury, which is a very significant concern. So this plant, although has been monitored, is probably being monitored for too few parameters, so you can't really tell whether or not there's you can tell that there's a plume out there, by the way, because you have a total dissolved solids plume that's from those data. That's the yellow boxes there, but I'm not quite sure that total dissolved solids would be a significant impact. However, mercury would, and that's not being tested out there. So that's one of the deficiencies of this, that you can't really tell whether or not this plant has had an impact unless you put in a number of additional wells to determine that. So to summarize, one of the questions that was asked of me is whether or not this scavenger waste treatment plant could affect the plume. And the answer is probably not, for two reasons. First, from a dispersion standpoint, it's unlikely that these two plumes are mingling, and that's because groundwater flows so slowly. In a river, turbulent flow occurs. In groundwater, it's always laminar. It's always very, very slow. You probably have velocities here in the tenths of a foot per day, things like that. So it moves very, very slowly, and because of that, it doesn't disperse much. The second question was, well, if hydrodynamically, could it affect the shape of the plume? And the answer is, if you put 60,000 gallons per day into the aquifer at that location, I did some calculations on that, and the mound that occurs is in the order of inches. So yes, it'll have some effect, but it's not going to be a substantial effect on the existing plume. And the existing plume actually is shrinking. The existing plume from the landfill is shrinking, and it's not migrating. So I don't think that from a hydrodynamic standpoint that any of that's going to affect it. But I do think that the scavenger waste treatment plant has shown that it does have a plume already, and that the notices of violation tells me that the quality control in accepting the waste is a problem at that. And there may be other things besides mercury that has kind of slipped through, and that really should be investigated as far as the impact of this plant, the scavenger waste treatment plant, on the aquifer. And that's our recommendation.
Thank you. Pretty good. Very concise. Thank you very much. Kim, I have you up next. Is that are you prepared to make some comments?
I actually don't have a presentation prepared, so if you want to just keep going.
Okay, so we'll go with Pio.
Yeah.
Thank you.
May I speak from here?
I have
Could I take in Kim's time?
No, not at all. We had you pretty well covered. Pio, the answer to your question is I don't know. That's a director's decision. I remind you that we're taping this, and the purpose of it is to have a product that we can redistribute after it's over.
Yes, why don't we shut the lights off just so everyone can see. Good afternoon, everyone. First, I want to thank the town board and supervisor for the invitation to speak with you. Let me go over just... posted on the web. Great. Okay. What I'm going to speak with you about is really septic wastewater management planning. From a practical perspective, the town's in an interesting position in that you're in a similar situation as if you had no septic treatment plant, because your existing septic treatment plant is beyond its useful life economically. And so you're really starting, if you will, with a clean piece of paper. So what I'm going to walk you through is how one figures out what to do and how to do it, and how do you integrate all of these pieces, and how do you deal with contextual issues. So hopefully this will assist you all in your decision-making process. Okay? So the first item here is, what is a septic management planning process consist of? The first item is you quantify the need. How much septic are we talking about? One very importantly needs to differentiate between septic treatment needs and failing septic system treatment needs. That's where I'll get into that. So you need to look at those separately. One then naturally identifies alternatives, one evaluates the alternatives from a technical, cost, environmental, and then performs what's referred to as a life cycle cost analysis. And then one refines what we call a preferred alternative from that suite, a menu of alternatives that were considered, and then one selects the preferred alternative. One identifies and evaluates management and financial options. Management options are, let me say broadly speaking, private versus public operation. And then deals with the financial aspects of it, from where you're going to get the money, whether it's grants, loans, etc. What's the user charge system? And then after that, one develops an implementation plan and schedule, and then officially adopts the plan. And that plan is the basis that gets filed with the town clerk and can be the basis for bonding, as well as any legal district that may be established. That's the, if you will, classical engineering procedures associated with putting together septic management plans that we've done for about 35 years now. So that's the overall process, and I'm going to walk you through how it applies to the town of East Hampton from let me call it a newcomer's perspective. When we look at the sizing criteria, as was said, you really have about 20,000 households in East Hampton. You have about a 20,000 population that's year-round and a 72,000 seasonal population. And then if I was to do, if you will, the book values of what to expect should be the typical septic generation from that community profile, I would say that the year-round population would generate about 8,000 to 10,000 gallons per day of septic, true septic, and that's a 250-day per year calendar. So it's a 5-day-a-week operation, and that the seasonal population is probably causing to be generated a similar quantity. So we're looking to treat, if it was a septic facility, I would say, gee whiz, you shouldn't need anything more than, if you will, 16 to 20,000 gallon per day system capacity. Now, you have a 45,000 gallon per day capacity. Apparently, that would look on first blush, well, it's a lot larger than needed. However, you all know, and we all know, that a significant percentage of that capacity is being used to dealing with failing septic systems that are being pumped on, let me call it, an emergency basis. So that helps in terms of context. And again, that's, if you will, book value. Now, to give you a little context in terms of I'm going to call them major observations on the scavenger plant. It's really being used for treating domestic wastewater, or commercial wastewater, and septic. And then if you look at the parameters of concern that are typical, like Mark was saying earlier, you'll see on a percent solids basis, typical wastewater is going to be 0.04 to 0.07% solids, whereas septage is 4% solids. So it's a solid material. Septage is a solid material. It's not really a liquid material, okay? And that's usually one of the major failures that's been around in the industry, is that it gets treated as a liquid when it's really a sludge. It's undewatered sludge. And then the nitrogen levels in, typical wastewater, these days, because of water conservation, it's typically more in the 60 milligrams per liter, whereas septage typically is 700. So it's a high-strength material, okay? So at your plant, the wastewater and the septage are commingled prior to treatment. So you're treating them like they're both the same, which in our opinion adds cost unnecessarily. So separating them, we think, on a first blush basis, should reduce some cost. The other key thing that's done in communities like East Hampton is that you schedule routine pumping during the off-season. And because routine septage pumping is routine. You don't need to do it at any particular time unless there's an emergency, and obviously that's not routine. And if you remember the numbers, you really the need for routine is less than half of what the plant can do. So if that was all scheduled during the off season, a couple of benefits. One of them, you keep the plant busy during the winter, and then secondly, you've got that capacity during the summer. Now, our basic major recommendations when we looked at the situation here is, again, looking at septage versus wastewater. First objective should be, in our opinion, reduce its use as a wastewater treatment plant by repairing failing septic systems, okay? And I'll get into that a little further. Also, you could even consider to have the scavenger plant to have dual systems, one that treats really septage and one that's really treating the wastewater, because you've got a lot of equipment there that's being used for septage, really, that is processing wastewater. So it's not being used, if you will, efficiently. You've had odor issues. If the plant is used for treatment, we would recommend, the simple requirement is to require positive ventilation and treatment of all foul air prior to venting. It's relatively easy to do, and it's really not that expensive to do. The other key issue is a manifest system. Right now, you really don't know who's there, and if you were to get a hot load, you would not know where it's coming from. What we would urge is a manifest system where, and this is done in a number of communities, where the property owner, if you will, purchases the ticket or for dumping the septage from the town, and then that ticket is given to the septage hauler, and then that ticket gets brought to the septage facility. So you have a quality control procedure to make sure that you know where it's coming from, so that if there is a bad load, it's relatively easy to track, which then diminishes the probability that there would be a bad load. The other issue is that you're operating the treatment plant as what we would refer to as a merchant facility. It's basically on a sort of first come, first serve, and whoever's here. Those are very difficult to operate for seasonal situations and in environmentally sensitive areas like you have. They're just a tough business to operate under. So the other thing I wanted to do here is also define some very important terms. As was mentioned, what is septage? Septage is what comes out of the septic tank. And I just show the typical cross-section of a septic tank. The objective in septage pumping is to get the solids out of the tank. Now, historically, the reason for that has been to protect the drain field, because when those solids get into the drain field clogs and it fails, okay? The rule of thumb in the industry has always been, and I'll go back here, that when the solid level gets to be more than 1/3 of the total level, that's when the tank needs to be pumped. Okay. However, things have improved over the last decades, and what's referred to as septic tank effluent filters are now commonly used and available. They're less than $100 each. They serve the function of protecting the drain field. So for those who are fastidious and want to get their tanks pumped every year or two because they want to protect the drain field, it's unnecessary. It's frankly a waste of money. The effluent filter does the job to provide that insurance. And the next slide here shows that you can see in what's called the effluent pipe there, that little arrow pointing to it, which it sits in that T, and it's a simple device. In the old days, if you will, we used to call them gas baffles, etc. And in some installations, there's an alarm attached to that, because if it gets, let me call it, dirty and doesn't allow the flow to go through, you're going to get backed up into the house, or there will be an alarm, and the operator just frankly someone needs to come by and frankly just wash it off. So that would be one of the techniques. The other issue here that I'm going to go through, and I'm going to be relatively quick because I don't have as much time as I'd like, is also how does one define failing septic system?